I had a question about MSL6 problem number 1. I'm going to go ahead and go through this one because this is definitely one that will be on exam 2. This is, one of these things that just consistently gives people trouble semester after semester. So I hope to use this video to make this a little bit clearer how you do this. So given a normal distribution, and this is number 1 on MSL6, with mean of 102 and standard deviation 15, and given you select a sample of n equals 9, complete parts A through D. Okay, so what I've done here is I've created an Excel sheet to help me keep track of all the information that I'm given. So basically we have these population parameters that we're given here. So these are characteristics of the population. So I'm going to write these over here. And these are distinct from the sample. So these are the sample characteristics down here. So I'm going to write down that we took 9. And then we're going to be asked about various sample means, okay? And so, for example, in this first one, it asks us about, what's the probability that the sample mean is less than 93? So I'm just going to write this down. So just a way of organizing some information. Now, remember that when we want to compute probabilities, it's helpful to convert raw scores into z-scores, which are, expressed as the number of standard deviations above or below the population mean. Now, when we're dealing with a large sample, or when we're dealing with a population, we can just calculate the z-score as the mean. Sorry, the sample mean minus the population mean divided by the standard deviation. However, because we have a sample here, the z-score is actually calculated kind of differently. So we're going to be using this form right here. So remember, we don't know, because we just have a sample, we want to adjust that standard deviation for the characteristics of the sample. So instead of just using standard deviation here, we're going to use the standard deviation divided by the square root of the sample size. Okay, so let's do this part first. We'll convert that. Let me just compute this because we're going to need this denominator. So population standard deviation divided by the square root of the sample size. So we'll put this here, and that is called the standard error of the mean. So this is just going to be equal to this standard deviation divided by the square root of the sample size. Okay, so that's something we're going to use in several of these calculations. Okay, so now for this, so the first part of this question asks me what's the probability of a sample mean being less than 93. Okay, so okay, let me go. Okay, let me get back to this. Okay, so what I need to do then is, first of all, convert this into a z-score using that particular formula. Okay, so remember that it's going to be equal to, okay, so this x bar minus population mean. Okay, we'll put that in parentheses to get our order of operations right. And then we're going to divide that by the standard error of the mean, which is here. Okay. All right, so this is the z-score of this particular observation, this mean, this 93 here. Okay, so now what's the probability of getting this value or something smaller than this? Okay, and so I have a column here to put this in, and I'm going to calculate this using the Excel norm dist. Okay, so now I'm going to put this in. Okay, and because remember this is I converted this into a z-score on the standard normal distribution, which means mean 0, standard deviation of 1. Cumulative is always going to be true there. Okay, so the probability that x is going to be less than this on a standard normal is 0.0359. Okay, and I formatted my sheet to have 4 decimal places already, so I'll have 0.0359. Right. Okay. Okay, so what's the probability that x bar is between 93 and 94.5? Okay, so remember that if we're looking for the probability of, a value falling between two numbers, then we need to take the probability of the larger one and subtract the probability of the smaller one. Okay, so, right here, remember that, if we're dealing with a range, we have to do the probability of the first one, the larger one, and then subtract out the probability of the smaller one. So let's do that. Okay. All right, so we've already calculated 93, so that's there. That's going to be here. And we just need to go and get, we need to figure out what's the z-score of 94.5. Okay. So converting this to z, we're going to do, it's going to be equal to this minus population mean. And once again, don't forget the parens. And we're going to divide that by the standard error of the mean here. Okay, so negative 1.5. Now we need to figure out what's the probability of this. We're going to use the same function, norm dist. Okay, remember that norm dist by default gives the probability less than. So we're going to just put that value in. And then standard normal, right? So we're going to do 0 and 1. And then we always put true there. Okay, so now the probability that it falls between these two, 93 and 94.5, is just going to be the difference between these two. So it's going to be equal to this minus this. Okay, so 0.0309. 0.0309. Okay, so now what's the probability that x bar is above 103? Okay, now remember that probability above is just going to be 1 minus the probability below. So let's figure out the probability below 103 and then just do 1 minus that. So let's do the same calculation over here. So now we're going to do an x bar of 103. Once again, we'll find the corresponding z-score. And once again, it's just going to be sample mean minus population mean divided by standard error of the mean. Okay, and now this time it's positive because this is above the population mean. We just need the probability less than this value. Let me just let me move this so that we can keep clear what we're doing here. Okay, so now the probability that x is going to be less than this value is going to be the same as above. So it's going to be that, mean 0, standard deviation 1, true. Okay, so this is the probability to be less than this. So the probability that it will be greater than this will just be 1 minus this. Okay, so 0.4207. Okay. All right, so now this last one is, it asks us to go in the reverse direction. So instead of going from a number to a probability, now we have to go from a probability to a number. And, we just have to be sure that, we're going to deal with it in the z-score, and then we have to go back from the z-score into the raw score. Okay, so we're basically going to be doing everything backwards here. So if there is a 63% chance that x bar is above what value? Okay, so remember that it's easier to work with less than. So if there's a 63% chance that something is greater than x bar, then that means that there's a 37% chance that it's less than that. Okay, so let's just deal with the 37. Okay, so we have now, we've got a probability here of 0.37. Okay, we'll just put that there for storage. Okay, so now we need to figure out, well, what's going to be the z-score of something that is going to have 37% of the probability mass under that PDF to the left. So it's going to be the inverse. So the reverse of this norm dist, we're going in the opposite direction now. So we're going to be finding this z-score, so it'll be just under this column. So now we're going to be doing the norm inverse, right? And then this is the probability, and we have a mean of 0, standard deviation of 1, okay? All right, so this now is a z-score. And if it asked for the z-score, that would be great, we'd be done. But now we have to convert this z-score back into a raw score, okay? Not too hard, because we know how to go in the opposite direction, right? So when we found a z-score, and just remember that wherever we see a standard deviation here, we're actually going to be using the standard error of the mean. So just imagine that that's the standard error. So when we found the z-score, we did x minus mu over standard error, right? So that means if we do some algebra, multiply that over there, and then add that there, what we wind up with is that to get back that raw score, we just take the population mean, add the z-score, times, and this should be standard error of the mean, okay? So let's do that. So we're gonna get back, we're gonna write raw here. So a raw score is going to be the population mean plus that z-score times, and this is the standard error of the mean right here, okay? So it should be, let me see, I think they do something strange with decimal places here. Yeah, 2 decimal places. Okay, so that means that the answer here is going to be 100.34. So 100.34. Okay, all right. So that's something, like I said, it consistently gives people trouble because you got to think, especially D there, you got to think of things in reverse. But if it's confusing, just do a few more of these, and hopefully that'll clarify that. Okay, good luck.